Welcome to this video on combinational circuits, a fundamental concept in digital electronics. Unlike sequential circuits, combinational circuits do not rely on memory or past inputs. Their output is determined completely by the current inputs. These circuits form the backbone of various digital systems, from simple arithmetic operations to complex logic design. A combinational circuit is a type of digital circuit where the output is determined entirely by the current combination of its inputs without any memory or storage elements. This means that the output is a direct function of the present input's values. These are key characteristics of combinational circuits, which are fundamental in digital logic design. Combinational circuits do not have any storage elements or feedback loops, meaning they cannot store or retain any previous state information. The output is determined entirely by the current input values without reference to past inputs. For a given set of inputs, a combinational circuit always produces the same output. This determinism means that the output is entirely predictable based on the input condition. The output of combinational circuit can be expressed through Boolean expressions, logical functions like AND, OR, NOT, NAND, NOR, XOR, and XNOR describe the precise relationship between inputs and outputs, allowing the behavior of the circuit to be mathematically modeled. These examples highlight some fundamental digital logic circuits often used in digital system design. Adder circuits that perform addition on binary numbers. Half adders add two single bit numbers and produce a sum and a carry output. Full adders extend to this to add three single bit numbers, produce a sum and a carry out. Multiplexer devices that select one of several input signals and route it to a single output. The selection is controlled by input signals called select lines. Decoders converts a binary input into a unique output line. For example, a 2 to 4 decoder takes a 2-bit input and activates one of the four output lines corresponding to the binary values. The reverse of decoders, they convert an active input signal into a binary code is called decoders. For instance, a 4 to 2 encoder takes one of four inputs and outputs a 2-bit binary representation of the active input. Comparators compare two binary numbers and indicate whether one is greater, equal, or less than the other. These circuits are useful in applications like sorting algorithms and digital decision-making process. The design of a combinational circuit involves several steps. The specification defines the desired functionality of the circuit, including the number of inputs and outputs. Construct a truth table that outlines the output for every possible combination of input values. Boolean expression deviation. From the truth table, derive the Boolean expression that represents the output logic. This can be done using methods like sum of products, expressing the output as a sum of products of inputs, product of sums, expressing the output as a product of sum of inputs. Use Boolean algebra or Karnaugh map, simply it is called K-maps, to simplify the Boolean expression to its minimal form. Implement the simplified expression using appropriate logic gates to form the circuits. Combinational circuits have a broad range of applications, including arithmetic and logic units within processors. ALU perform arithmetic operations like addition, subtraction, multiplication, and logical operations like AND, OR, XOR, and NOT. Combinational circuits form the core of these operations, providing the necessary logic for quick computation within the processor. Multiplexers and demultiplexers are essential for directing data through different paths. Mux selects a single output from the multiple input lines, while Dmux routes a single input to one of many outputs. These circuits ensure efficient data transfer in communication systems and memory devices. Encoders and decoders are used to convert data from one form to another, like converting binary data to a format suitable for display or communication. Encoders compress input signal while decoders revert them to their original form. Combinational circuits are used in digital signal processing to manipulate and transform digital signals. Examples include adders, multipliers, and digital filters that process sound, images, or other digital signals to improve quality or extract useful information. Thank you for watching.